pleasure to welcome Rachel Harrison to speak to us tonight, to give the last presentation in this year's programme. She's a local girl, really, with a first degree from this place and a PhD from Southampton. Became Professor of Computer Studies at Reading, Computer Science at Reading, I should say, and is now Professor at Brookes. I've came across her name when I was doing my TOGAF exams some 10 years ago. That's the method for enterprise architecture, and she wrote the textbooks. So, and then I later on noticed that she was also Editor-in-Chief of the Software Quality Journal, which is the leading journal in this field. And here she is locally at Brookes, very conveniently able to come and talk to us tonight. So please give Rachel a warm welcome.
Thank you very much. I hope you can all hear me okay. Everybody hear me at the back? Yes. As John was kindly saying, I do in fact have lots of different hats to wear. So there are a few hats I can wear, and one hat is the enterprise architecture hat, but that's not one I had intended to put on tonight, I must admit, because that's something that I did a while ago. But what I will do tonight is to try to wear two hats, if I may. One is as the Editor-in-Chief of the Software Quality Journal, and the other is as a researcher at Oxford Brookes, and so I'd like to tell you what we've been about the research that we've been doing there as well. So the first bit of the talk is about Software Quality Journal. So I think I'm very lucky actually, because this means that I get to see research from many different aspects. So I get to see what everybody else is doing, which is great, because we get all these papers coming in and I'm the first one to see them, and I have to do various things with them, which I'll describe briefly. And so I get this idea of what's going on, and I think I have put a few slides in here that try to give you some of the feeling of the sort of things that we publish and the sort of things we have been publishing this year. So it's very much hot off the press, this talk, in fact. And then, I'll also talk about some research that we've been doing in AI. And I have heard about the huge donation that somebody has made, luckily, to Oxford this week, in fact, 150 million, thank you. So a huge amount. So unfortunately, I don't come along with that sort of money, but it does show how much interest there is in AI nowadays, and I think this is absolutely right, because computers are here to help us. They're not here to burden us, and that's perhaps something that we tend to forget sometimes. We feel that we're just deluged with information, and yes, I've got to log on, and I've got to do my Fitbit, and I've got to look at this, and I've got to look at that. But in fact, computers should be our servants. They should be helping us. They should be seamlessly there in the background, just helping us as we go along. And surely AI is part of that solution. But having said that, of course, we mustn't forget there are many questions over AI as well. We can't just use it and say, yes, that's it, let's go. But we have to think about the ethics all the time as well. So, without further ado, what are we going to do today? So I'm going to say, yes, a bit about the Software Quality Journal, because I'd like to advertise it and to encourage you to actually submit the papers. I'll talk about how to get your paper through, if you would like to do that, and the process that we go through in order to make sure that everything is rigorously refereed. And then I'll go on to the second part, which is talking about AI for software quality, particularly the stuff we've been doing on automatically classifying requirements from app stores. And I'll finish with some upcoming special issues, just in case, again, you might like to try to aim your papers at one of those issues. I'm happy to take questions as we go along, but we'll also take them at the end as well, of course. Right, so a little bit about the journal. So really, the idea is that the journal is all about software quality, and so how do we get good quality? And so there are standards out there which people adhere to try to make sure there is quality, but also it's a bit wider than that. So if you think about verification and validation, then we're quite keen to publish those sorts of papers as well. So we have quite a lot of formal methods papers, and that's the middle bit, which is describing the methods, the tools, the products to use and to measure quality as well. And we're addressing all aspects of software quality. Oh dear, that's not quite what I wanted to do. Right, and then we're going to, yes, it's from a practical viewpoint as well as from the academic viewpoint, and we do publish stuff from practitioners as well as from academics, so as well as national and international bodies. So, having said that, I think the vast majority of the papers probably are quite academic, so we do have an impact factor, and I'll talk a little bit more about that later. Right, there's the editorial board. So this is my 10 good men and true, except of course it's more than 10 and they're not men, not all men. So yes, I've got a lot of people to help me, particularly the associate editor who's Sudipto Ghosh, who's at the top there on the top left. He's at Colorado State. He does a lot of the pre-reviews. So when the papers come in, we have to filter them to make sure that they are in scope. And so that's just a very quick look, really, just looking at them to see whether they are journal quality. So we do all of that, and then we have this editorial board, which is quite large, but what I have to do is I have to find an editor on the editorial board who will then take care of the paper as it goes through the process. So then I'm hoping that somebody will step forward and put their hands up and volunteer to actually shepherd the paper throughout the whole process. So we've got a long list there of colleagues. What else? This is 10 full text article requests in 2017. So I thought you might be interested to see the sort of papers we get in, but also how many requests we get for them. So if we have a look, the top one is which process metrics can significantly improve defect prediction models, empirical study thereof. So, and that's by Lex Modesky, and that got 1,599 article requests back in 2017. So that's a good example of an original paper that was published and the sort of research that was done back in 2017. The second one is also on defect prediction, so we're beginning to see a bit of a trend here. And the third one is test automation, so once again it's on verification, validation. Then we've got something on risk-based testing, so yes, we certainly do have a lot of testing. What else is interesting here? Oh, there's a special section towards the bottom on realising artificial intelligence synergies in software engineering. So that was a special section on a workshop series that I started back in 2004. So it's a long time ago now, but we have workshops usually associated with the International Conference on Requirements Engineering, and the papers from there we had a special issue just with those papers. So again, that's something which is extremely interesting, and I'm sure I hope it will continue to run. So that's just a quick glance at something from 2017, what's going on there. On the outline issues. So this is, again, 2017, showing you the special issues that we published then. So we had one on program debugging and there was two special issues. One on program debugging, and the other one was the realising artificial intelligence synergies in software engineering. That's the RAISE workshop series. So I actually started two workshop series. One is called RAISE, and the other one is called AIR. So RAISE is this one on realising artificial intelligence synergies in software engineering. So it's quite a nice acronym, I think. That one has gone from strength to strength, and it's held at ICSE, the International Conference on Software Engineering, annually in May. It's end of May, beginning of June. So that one, the call has already been and gone, I'm afraid. But it was the best. It had the most papers submitted to it last year of all the workshops that there are at ICSE. So I think that shows just how much interest there is in this area. So that's, again, going from strength to strength. We had a special issue on test automation for software, and the third special issue was collaboration in software testing. So again, you can see the theme. We've got a lot of testing going on, and a lot of people are quite interested in publishing in that area. A quick look at the summary of the submissions. So for each year, total submissions, it's Yes, 230, then 170, and then 180. So it's sort of bobbling around, not quite 200 a year at the moment. So 184. These are 2017 figures because I've timed this talk so perfectly that the statistics are all due out next week, the new statistics for this year, unfortunately. So I've been trying to get them, but haven't quite, unfortunately. So you can see that we had 184 submitted. On those, we made decisions on 168, of which 37 were accepts. So you can see that there is quite a cut-off point there. It's relatively difficult, I would say, to get published. There are some transferred and some withdrawn. So it ends up with a rejection rate of 74%. Oh, we've also got the average days to first decision, which is 83. So a lot of people ask me this question, how long is it going to take? And the answer is, well, how long is a piece of string? It takes as long as it takes because I'm relying on the reviewers, and the reviewers are giving their time freely, and yet I can't pay them. So what do we get out of it? So it's very difficult for me to actually crack the whip and encourage things. I obviously do try to make sure that papers move through the system and are not sitting there forever, but it can be difficult. But about 3 months to the first decision.
Why does it take so much longer for the final decision?
It's, to get an accept is even more difficult because for the first decision, then it goes back to the authors because the first decision might be revised and resubmit. And then the authors need some time.
Yeah, okay.
And so, yes, then the papers come back to us and then they have to go out again. So, yes, it is quite a process. Once I do get a recommendation, I do act immediately. So I like to think I'm not the bottleneck. Right, okay. So I did a word cloud with the, this is the titles of papers that were submitted in 2018. And quite pleasingly, we have got, you can see software and testing and quality in there cropping up immediately. So that was quite a nice visual display of the sort of things that we do get submitted. What else have I done? I've done one with the keywords. So the first one was the done on the titles, whereas the second one is the keywords, and that one was really nice because it definitely came out with software quality right in the middle there. That's perfect. What else can you see here? You can probably see that we've got maintenance in there, which is, yes, visible there, and just above that, and effort, as well as requirements, performance, those defects as well, and classification. So, quite interesting, I think. It sort of it gives you a rough feeling for the sort of things that do come up, what sort of keywords the authors are using. So here's the process that I was trying to describe a second ago. So, yes, you submit, you decide I've got something to say, so you submit your paper, then I assign it to an associate editor if I can find one, then that person then has to assign the reviewers. That can take quite a long time because we need to find hopefully at least 3 reviewers who are actually willing to give their time up to actually do this. Then when we get the reviews, that they've done them, then we can make some decisions. So then either it's accept with minor changes, which is the quickest turnaround, or else it's a revise and resubmit, which can take much longer. Or it's a reject if it's really not very good. And coming out at one side, you can see that we have got the publish, so if we are successful. That's basically the process. So it is quite a long process, and many people are quite surprised about this if they haven't published that much before. They seem to think, yes, they just submit it to me and then I make a decision there and then, but that's not the case. Of course, I do rely on that associate board that I've got, so it's a very long-winded process, unfortunately. I did a keyword frequencies analysis as well, and so here we have phrases which are 3 words together and then counting how many times this happened. And this is again for the 2018 papers. So we've got model-based testing, as you can see, and test case and testing test case. Software defect prediction is up there, and model-driven engineering is another key one. The others are just slightly less frequent, but two words occurring together. Then there are quite a few things that are coming forwards now which didn't come before, such as mobile testing, for example, and machine learning, and software defects and software testing, I think, have always been there. I don't think there's a new. So those are the keyword frequencies, and title frequencies, again, quite similar. I think the model-based testing was on the other slide, and software defect prediction was as well. So those are the sorts of things that we see. Impact. Why have I put this in? Highest cited articles. Again, so this is to give you an example of what sort of papers you should write if you want to be highly cited. So the top one is the project managers in global software development teams. Okay, so this is another very hot topic. So we get lots and lots of papers on global software development. So people trying to work out how you work together all over the world. So you're doing collaborative software engineering. And there are lots of theories and hypotheses that are coming forwards about how to work across time zones, for example, and how to avoid cultural clashes when you're working with people from other countries and the states. So we've had quite a few papers on that. The second one is process metrics, defect prediction models, again, very, very popular. The third one is test case prioritization, using ordered sequences of program titles, entities, that should be. Bottom one is failure severity in safety critical software. So that's another topic that we do get quite a few papers on, and had quite a few citations. Impact. So how much impact does the Software Quality Journal have? And yes, I'm afraid you can see that the Software Quality Journal, when it's in the ranking, is in fact down there. So perhaps we should gloss over this slide. But it is an interesting slide, and I quite like to put it in actually, because I like to see where IEEE software is. It's sort of in the middle. You can see it's got the impact factor of 3.3, which is sort of quite nice, whereas the Software Quality Journal is down at 1.7 in that example. But there are lies and damn lies and statistics, so and certainly we can take impact factors with a pinch of salt, really, because yes, they come and go, and we don't want to get too worried about it, really. So this is the journals that cite papers that are in the Software Quality Journal, and also the papers that are cited by papers within the SQJ as well. So again, this is perhaps not surprising to you that we should find something like IEEE Transactional Software Engineering very close to the top of both of those tables. So, how, you say, can I get my paper accepted? Well, this is the big question, isn't it? Really, this is the question that we all want to know the answer to. So, a couple of things, really, that I need to say. Firstly, avoid a desk rejection. That is crucial, absolutely. You don't want it to land on the editor's desk and they say, no, that's not right, we're not having that one. And that is the first thing that we do. We look through it, and as I said, a couple of us look through the papers just to see whether they are in scope and whether or not they've got their research questions. So these are fairly basic things to look for. And then, do they actually bother to answer their research questions as well? And do they have an idea of what they might have done wrong? So can they address the threats to the validity of the work? So if a paper can do that, then that shows that it's a good, well, potentially journal material. And hopefully there will be a good literature review in there as well. And in fact, we do have to look to make sure that the English is okay as well, because we don't want to. Well, copy editing is extremely difficult, and it can be nobody's happy if they have to end up with having to copy edit a paper just to put it into English at the very end. And then there's the legal requirements as well. So luckily, because I've got this team working with me.
Do you do a plagiarism check?
We do, yes, indeed. That's what I'm.
That's rejection, is it?
Yes. We have there are tools which you probably know about that we can run it through. But the team of editors on the editorial board are very good, and because they're all researchers, they know what's been published recently, and they can usually spot fairly quickly if something else has been submitted somewhere else at the same time. And surprisingly, these things do happen, unfortunately. And then we have to obviously read those papers out. And as you're suggesting, yes, there are tools that we can use very helpfully to get us through this as well. So there's a nice tool called Authenticate that we use a lot. And so you can run the new submitted paper through that and find out the percentage of duplication from previously published papers. And so, yes, if that's too high, then again, that would not go out for review. So those are all the things that we're trying to check at first to make sure that we don't get into any legal problems, because it's best to avoid the legal problems. So as well as all that lot, you have to do something that's novel and interesting, and it's got to have a research message. So we want to say, what is the research that I can take home from this? What is the research message in this paper? And then, of course, because we send it out to reviewers, we get a lot of reviews back, and then that means that what we'd like the authors to actually read these actual reviews and answer all of the queries. So that's, again, is why it takes quite a long time to actually do the publication process. And sometimes the authors quite simply cannot answer the reviewers sufficiently and can't do it, in which case there would be a reject. But usually the authors will work hard, and then because it goes back to the original reviewers, we can find out whether or not it's been all of the queries have been answered. And the bottom line is be patient, because all of that process takes a while. And we did have a huge logjam, in fact, at the Software Quality Journal, unfortunately, but we did a lot of publications last year, and so we've sort of whittled that down now. And we have something called Online First, and that means that as soon as it's been accepted, well, pretty soon, we can then put a paper online, and so everybody can then read it, and so you'll get an instantly published paper, hopefully, rather than having to wait until next year. At the moment, I think the papers that we accept this week will probably be published in 2020, maybe 2021 on paper. Yes, but online they can be published next month, perhaps. So if you want the hard copy, I'm afraid you have to be very patient. Yes, so I think this is the second part of my talk. So that was enough of the Software Quality Journal.
Question before you move on.
Yes.
Do you have an open access policy?
That's a good question. Right, open access. The answer is that, I'm trying to think because we've just changed it. Springer Nature have got an agreement with a certain number of institutions. Yes, and Oxford is one of those institutions, so that the papers can be open access. So I believe that the answer is yes, but it depends which institution you're at.
Research Council's policy is moving towards open access for all publications.
Yes.
So
Yes.
journals in the UK do need to have open access policies.
Yes. Indeed, that's right.
So,
Yes.
So it needs to be across all the institutions.
Yes, it does. I was looking at the list, and as I say, I was very pleased to see that Oxford is in. Unfortunately, also Brookes is not. So, again, this is... yes, there are obviously some communication is taking place and some negotiations are taking place right now, and the list that I saw I think it was yesterday or the day before, had about 70, probably about 70 institutions in there. So it's not everybody, but it's quite a few. So that's good. And
processing charge model available, that goal open access. So after the processing charge model, where people can sort of pay.
yes,
It's open access.
that's right. So certainly there's a choice. You can pay and make it open access. Yes, if you prefer. Is that okay? Any other questions on the Software Quality Journal before I move on to the next bit? No? Good. Okay. So I'll talk about AIR. So AIR stands for Artificial Intelligence and Requirements Engineering. And this is a series of workshops that we started, and they're co-located with the Requirements Engineering Conference, the IEEE conference on this. And so last year was in Banff in Canada, and that was very nice. This year it's in Jeju Island in South Korea, and it's nearly always in late August or early September. And so what we wanted to do with this workshop, or series of workshops, was to actually explore the synergies between AI and requirements engineering. And what we're trying to do is, in that way, to improve software quality or requirements quality particularly. So there are many ways, I think, that AI can help to automate this process. As we all know, it's very, very difficult to get requirements, and we're probably never going to get the right requirements. So if we can just find some way that we can iterate and go many times around the loop until we get some requirements which are at least satisfactory, or at least we can get some sort of satisfying situation, then that would be quite good. And so surely AI must be able to help with this. So what else was I going to say? Topics of interest, yes. So all these sorts of things. So requirements engineering, quality models and their automation. So quality, as you know, is a huge thing. It's difficult to narrow it down, wrong to try and narrow it down, because it has many, many aspects. So we're thinking about all the functional requirements and all the non-functional requirements, and then how do we satisfy those, or satisfice them, and then how can we automate them. So the idea is that there's no one quality model. What we need is a template, and then you make your own quality model to satisfy or to fit the particular context or application that you're working on, and the environment that you're working in as well. We like and get a lot of papers now on natural language processing and comprehension. So we're seeing more and more papers in this area coming along, and again that is going to help us, I think, to automate getting from the requirements and then getting them into the system. So the next couple of points are all on natural language semantic. Machine learning techniques, which we will talk about a little bit more, including all the supervised and unsupervised and machine-human interactions, artificial neural networks and deep learning. Of course, this is, again, relatively new, but deep learning is really helping a lot in this area nowadays. So we can do quite a lot in this area and make some great leaps forward. Detection of uncertainties, ambiguities. Well, of course, Manny Lehman started this all off many, many years ago when he said you don't know what the assumptions are in your system. And this is very true, and we still don't know. We still can't tell what's going on in somebody else's head. So what are the unwritten assumptions? What are the hidden assumptions? Is there any way we can find the ambiguities? And yes, it is extremely difficult. So perhaps we can use some logic-based reasoning to do that and try to formalise and automate things that way. For that, you might need to do some knowledge acquisition, and you would need to look at representation of the knowledge. And you could look at agent-based solutions as well. Decision-making support mechanisms are increasingly important, and so again we do encourage papers along those lines. as well as optimization techniques and any automated approaches for prioritisation of requirements. Again, very important. So we're encouraging two sorts of papers. We can either accept the full research papers of 7 pages or a short position statement, which is just 4 pages if you have an idea of something that you might want to explore. And the dates are coming up July the 5th, 2019. That's a key date there. So now I'm getting on to the research aspect of the talk. And I wanted to talk to you about some research I've been doing at Oxford Brookes and with a colleague, Daniel Rodriguez, who's at the University of Alcalá in Spain. And Daniel was my PhD student when we were at Southampton together. And Roger Diacardis is my research assistant here at Oxford Brookes University. So we published this as AIR back in 2017, and that was in Portugal. And what we wanted to do was try to automatically classify the requirements from app stores, because I don't know if it says on the next slide. No, it doesn't. Right, so app stores, of course, are wonderful sources and repositories of information, because now we have these app stores, so everybody can get their apps from there. But not only that, they also upload to the App Store what they thought about the app. And that's wonderful, a wonderful source of information for the developers, and not only for developers, of course, but also for users and for all stakeholders, because for managers trying to decide what should go into the app next time around, on the next iteration or the next version. So we have these app stores, and as I say, these are fantastic repositories of information, but as I was mentioning right at the very beginning, there's too much information, unfortunately. So how on earth do we make sense of all that information? People are just uploading their random thoughts, and perhaps it's not even in English. It might be written with all sorts of hieroglyphics, exclamation marks, and words that we wouldn't like to repeat, really, but out of their frustration, perhaps, with the apps. But so people are not using English, and it's not written well, and how do you use natural language processing to make sense of this, and then to deliver to the people who need it, the software developers presumably, at the end of the day, some information that says, well, people like this in your app, but people would love to have this next time round. So it's really like looking for the golden bullet. It's searching for a needle in a haystack almost, trying to find out the features that are the most interesting ones. So that was the idea, and that's what we thought we'd like to do. And then we thought, well, surely we can use AI to help us to do this, and we thought perhaps semi-supervised learning is the way to do it. And so the next bit I have to talk to you about is, what do I mean by semi-supervised learning? So, as you might expect, it's somewhere between supervised machine learning and unsupervised machine learning. So it's not surprising then, really, that's halfway between them. But the thing is that you've got this data, but there's too much of it, unfortunately. So we can't all label every item in the data, every data point in this set of data. So that would take far too long. That would be fully supervised learning, but we don't want to do that. It's just going to take too much effort for the human beings involved. So what we'd like to do is we try to do some semi-supervised instead, because that's sort of in the middle of everything. It's not fully supervised and it's not unsupervised. We think we can probably get enough information doing it this way, but and yes, it won't actually use all that much resource. So as it's saying at the bottom, this is probably what's going to happen if you're doing some natural language processing with web documents, or some text mining, or if you're also labeling images. So it would look also, this sort of technique can work with images that you're trying to look at. So when you stand in front of the photo, in front of the camera when you're going through the passport control and something is trying to do some image processing on you, then again there could be something which is doing semi-supervised machine learning at the other end of the camera. So how do we do this? Well, we've got this data set, as I mentioned. We call the data set D, and in the data set we've got a union of the things that are labelled and the things that are unlabelled. So the labelled is the set L, and the unlabelled is the set U. We've got a learner function. This hasn't quite come out properly, I'm afraid. It's supposed to be an arrow, straight arrow, from X to Y. And we've got some labelled data. The labelled data is the data in pairs. So you've got an xi together with a yi. So you've already labelled the x with the y to say which class it is in. So, for example, with those reviews that I was talking about a second ago, then you've got this review and somebody has written in, this is a great app, but then what we'd like to know is, is this person complaining about a bug, or are they asking for a new feature? Because then we can hand that to the developer and say this is a new feature, or the developer then has an idea of whether they're looking at bugs or features. So we'd like to label this data, as either a bug or a feature. So that's going to be the yi, as you can see on that slide. And then you've got some unlabeled data, which is all the data we didn't have time to look at. And that will be available during the training. So, if I can get this to work. Yeah. And then we've got some test data that we're going to use to do the testing on as well, which is completely separate from the training data. And there are two sorts of machine learning that we might do here. One is called inductive and the other is called transductive. So with the inductive, we're trying to predict a label on the future test data that's coming in. Whereas for transductive, what we're doing is we're trying to predict the labels on the unlabeled instances that we've already got in the training sample. So we've got two separate samples here, two separate ideas. So you might say to me, well, does it work? Yes, that's a good question. Does it always work? Well, there are some assumptions, going back to assumptions again. One of the assumptions is that we have a smoothness. We're assuming that all the data is smooth. So if I've got two different points, x1 and x2, and they're in the high density region and they're close, then so should be the classes that they are mapped into. So that's a smoothness assumption. We're also using a clustering assumption. So if the points are in the same cluster, then they're likely to be the same class. So if they're clustered together, we think that these are probably going to be both features that are required, or they're probably going to both be bugs. And there's the low density separation assumption. So the decision boundary, which is drawn automatically by the machine learner, should be in a low density region ideally. So you'd like to have it drawn where there's not too much data. Otherwise, it's very difficult to separate the points. Oh yes, here's a picture of those points in actual fact. Right, yes. So the labelled data are numbers 1 and numbers 2. And so if I were to ask you how would you classify this, you might be tempted to draw a line where the 0 is. You might say it's going to go up there, perhaps. But then with semi-supervised learning, what we do is we have a look at all the unlabelled data, which is drawn as the open circles, empty circles, and we can see that it's clustering. There's a lot of it there, and there's a lot of it there. And from that, visually, you could make a decision that we're going to move the decision line by delta and shift it over to here. So that's the idea behind semi-supervised learning. So the idea is to try to use the density of the unlabelled data to give you a clue about where the decision boundary should actually be. Okay. Right, next bit. Semi-supervised learning. Right, we're doing The next bit is self-learning methods. Right. Okay. That's just... We are using self-learning methods for this. It's a sort of taxonomy, because it's a little bit more complicated than I have just described. And so at the top there are self-labelled methods. So basically what the algorithms do is they do self-labelling. So they'll take a little bit of the training data and label it, and then feed that back in to the data and use that again to do and iterate until we get close to a decision. But this slide is trying to say there are many different ways of doing this. So the multi-view idea on the right-hand side is that supposing you had a phrase that said it's got the phrase Mr. Washington in there. So the way that you would actually try to parse that will depend on whether you're looking for a person or looking for a state. So you need to have the context, in other words. And the multi-view on the right-hand side is saying that, yes, we're going to use the context and look for two things rather than just one. So it's thinking about things from different viewpoints. And so the algorithms that you can see at the bottom of the slide, which is called code training, RASCO and relative RASCO, those are special algorithms if you happen to be doing a multi-view machine learning algorithm. Whereas on the left-hand side, we've got a single view going down to single learning and self-training, and those are the sort of algorithms that we do tend to use quite a lot if we're just going for something that's much more straightforward than that. So that's a taxonomy. This is taken from a paper by Triguero et al., and that was published back in 2014. So now I have to talk about the problem. What is the problem? The problem is trying to classify these app store reviews using this semi-supervised learning as I was describing. So this is what we wanted to do. We wanted to have a look at both trying to do some transductive machine learning, that's predicting the labels during the training, and also the inductive machine learning, that's trying to predict the labels on the unseen future data on a data set of reviews that we've collected from the App Store. So luckily there are lots of reviews that we can get. So the Apple App Store, for example, has millions of reviews which are quite easy to download and so there are lots of repositories that we can use, and we can crawl these app stores to get the data we need. That was describing the problem. Now let's look at the data set that we've got. Oh yes, so this is more interesting perhaps, because this gives you an example of the sorts of reviews that you might see. And so what we had to do was we had to manually label some of these reviews so that you can then start off the process. You have to bootstrap the process you need some sort of golden truth set that you can use to test the machine against as it's learning. So the first one says, great app before, but now it's getting worse, selecting the incorrect routes and sometimes stuck in the previous position. I hope you get this fixed. And so we've gone through that and said, right, that's a functional requirement, and that goes into the functional class. The same with the next one, can't see the traffic colours now. With the latest updates, I can't see the traffic, red, green, yellow, etc. And then there's a non-functional one. This said lags Google Maps and lags so much now. And then you get a bit of information about what the person's using on the iPhone, what sort of phone they're using, and just a line saying you've lost me, Google. So we'd label that as being non-functional. So this is where we're trying to classify the reviews into whether they are functional or non-functional. Any questions?
Do you classify the apps? Because the comments which make sense, you're going to sort of the app intentionals in terms of what this is something to do with perhaps navigation of
Yes.
the review. So if you knew that up front,
Yes.
help understand or decode the comments.
That's true. Yes, we chose a small selection of apps from a variety of domains. So we did have various domains, in fact, and also we did restrict ourselves to looking at non-paid apps as well, because I think there is a difference between whether apps are being paid for or not. So yeah, that's a good question. There's quite a lot of research that's going on in this area about trying to work out exactly what we can do to narrow things down a little bit. That's a good point. Thank you. Yeah. Right. So, as I was saying, this data that we get is very mixed. So we've got a lot of text here. How on earth do we deal with it? And of course, you can't just feed this straight in to an algorithm. You've got to pre-process it first. So what we do is we transform it into a vector of words, and we're using Weka, which is the Waketo knowledge acquisition toolkit. So, and that's very good because it's got all of these things built into it already. For example, you can do things like decide whether you're going to use a stemmer. So you probably would use a stemmer because you don't need to know the whole word. You cut off the end of the verb, for example, so you get just the bit of the word that you're most interested in. So we had certain parameters that we knew that we had to use for the pre-processing. So we had to do a lot of pre-processing. And there's another tool that we've used as well, which is called Keel. Again, this is from Spain. And I can't quite remember what the algorithm is, what the acronym is. It's knowledge extraction, evaluation, something or other, I think. So Keel is quite good. I don't know if any of you have used Weka or Keel before. Looking around the room, any volunteers? No? Weka is perhaps more well known than Keel, but nowadays, of course, you can do an awful lot in R as well. How about R? People happy with R? That's quite a good tool for doing all this sort of thing. And for people who are happy with Python, then that's the natural tool that you would go to in actual fact nowadays. But Keel and Weka have got a lot of stuff built into them, all the algorithms that we actually need. Right, where are we? We're on to self-labelling algorithms, I think. Yes, a bit more about the algorithms. So I mentioned self-training a little bit at the beginning or in the middle. Using a base classifier, the unlabeled data are labelled and then they're added back into the training set, and then you loop and iterate on that. With code training, what you're doing is you're going to have you do it in two different ways, and then train these two things independently, and then they help each other, which is quite good. We've also used RASCO a lot. This is random subspace method for code training. It's very similar to the code training, but this time with multiple classifiers trained on different attribute splits. And then there's also relative RASCO, which is similar again, and it's again another algorithm that we have used quite a bit of. It's quite good. I'll show you some results in a second. Self-training. Oh, this is a description of self-training, yes, which I did give you a minute ago. So you learn with the classifier F using the labelled data, and then you label the unlabelled data with that function, and then you add the new labelled data back in to the learner and take it from the unlearned set. And those are just our parameters, what we did. We set it as 40 iterations for all of those. And the base algorithms we used were, and you might recognise some of these perhaps, we used the k nearest neighbours, which is quite a well-known one, which is, you've got to, we set the number of neighbours to be 3, and we were using Euclidean distance, so you're just looking at the closest distance between two points. We use the C4.5 algorithm as well. We use naive Bayes. It has been shown, as you may know, to be a very good algorithm for doing this sort of work, perhaps the best. And we use SMOTE, which is the synthetic minority oversampling algorithm, and we used various parameters with that one as well. So this slide shows 4. There are many more, actually, algorithms that you could use, but the nearest neighbours is perhaps the most famous because it's the simplest, but you could say that about naive Bayes as well, of course. We're on to the results now, you were pleased to hear. So here are the results. And then we've got a nice radar diagram, and what do we show? We're showing here that what happened was, this is the inductive accuracy, which you remember we're trying to label things that we've already got. And what you can see here is that we've got the results for if we had labelled 10% of the data, and if we'd labelled 30%, 50%, and 70%, where 70% is the blue, which is the outside loop, which is what you'd expect. You expect to have the best results for the data that you had most labelled, and the worst results are for the 10% of the inside loop. But I think perhaps the things I would like to point out is that there's not a huge amount of difference between the 10% loop and the 70% loop. So I think you can do quite a bit, even if you've only labelled 10% of it, if you're using a semi-supervised learning algorithm. And what about transductive? So this is trying to predict in the future the test data you've not seen. The loops look a little bit different, but the basic message is still the same. So there's not a huge amount of difference between the data we had labelled 10% of, and the data we'd labelled 70% of. So I think this is a good result for semi-supervised learning. We've actually got the tables here which have got the numbers in them, which only means something to you if you know what exactly you're looking for here. What we're looking for is that numbers that are getting close to 1, and you can see that on the right-hand side we've got the data that's 70% of it was labelled, and so the numbers are starting, as you can see, at 0.59, and they're going up to, we've got a 0.7 in there, which is with naive Bayes, and there's a 0.73 at the top actually, which is the C4.5 algorithm, which is pretty good as well. That's with the 70% label. If you go back to the 10% label, I would say it's still not that bad, really. You can see we're getting close to 0.6. There's one which is 0.67 there. So we're sort of getting towards we're going in the right direction.
So why is RASCO KNN going down?
Yes. Yes. There must be something wrong with that one. Yes. Yes. That's right, at the end it does. It goes, so the one that was 70% that you're right has gone down. Yes.
To be investigated.
To be investigated, exactly. Yes. Yes, thank you. That's another table with the same sort of thing. So, in conclusion, I think we can get some pretty good results, which are similar to what you'd get if you'd supervised the classification with less data, with less labelling. So that's good. But there can be big differences depending on what base classifier you've used, whether you've used naive Bayes or something like C4.5 or RASCO, then there can be quite some big differences. And you can apply further algorithms with this technique as well, so you can iterate as you wish. In the future, what we'd like to do is we'd like to look at problems from imbalanced data, because if you put garbage in, you get garbage out. So we all know that, don't we? So if the data is imbalanced, that means we've got a huge number of bugs versus a small number of requests, for example. So if the data is too unbalanced, it's much more difficult to analyse. We'd like to use the whole data set. So far we haven't done that. We've only used a little bit of it. But by that I mean there is a lot of data out there and we haven't used it. And the thing is that some of it's not in a form that's easy to use. So sometimes you'll see something like the stars, for example, or people will put in exclamation marks, or 3 exclamation marks. What does that mean? So how do we get that information? And the bottom point is meta-learning. So can we check the characteristics of the data first? So I think that's perhaps a very important point. So we are working on some research which we're calling learning to learn. So if we knew a lot about the data before we went in, then we can make some really good decisions about which algorithms to use, and that would be much, much more intelligent, basically, than the sort of stuff that we're doing right now. I wanted to tell you about the upcoming special issues as well, so it's a bit more putting the other hat on, back on, the Software Quality Journal hat back on. We've got some upcoming special issues which are still, the deadline is still to come, so you're not too late. You can see the first one is in September, we've got some in November coming up, and one even in January next year as well. So if you wanted to write about improving software quality through program analysis, or if you wanted to write about verification and validation of adaptive software, or software quality in free or open source software, and again that's another special issue we've got coming up, and the testing of software and systems looks like being a good one, and that is going to be, has a submission date of January next year. So pens at the ready, everybody, and try and get those papers written. What else? Summary. Yes, I thought I had something else. Right, about the Software Quality Journal. So that's all about quality, and we're going to look for things like testing and software engineering, etc. How to get your paper accepted? Well, try to avoid a desk rejection. That's the first point. If you've got something novel and interesting to say, that's even better still. Try to help the reviewers by actually answering their comments and not just ignoring them, and do try to be a little bit patient. What else? I've given you an overview of AIR, so I'd like to encourage you again, this deadline is coming up, July, did I say it's July the 5th? It's coming up in a couple of weeks' time. So if you have a short paper ready to go, then that will be excellent. We're very happy to see that. And that's bringing together requirements engineering and AI. And what else? I talked to you a bit about machine learning, about how we have tried to automatically classify requirements from the app stores. So I described a preliminary study that we did, and we are still going on with that work because you can see it's nowhere near done. But I think perhaps... this references papers, how to get your paper accepted. That's quite a nice little slide. And that's the references for the machine learning, some of the machine learning that I was talking about. Right, thank you very much. Any questions?
Okay, if we're all done then, thank you very much, Rachel.
Thank you very much.